Anyway, Shaira, hope you settle with whatever, because I'm not sure. Okay. Even I'm not sure even your academic advisor asked you, or it's just me asking you. Or did other lecturer didn't ask, only me? I don't know. Never mind. At least I'm asking because out of my concern. Okay. So we have been finished until convert to no logic until this part. Okay. So the week 8 is actually about multiplexer and decoders. So we're not going to cover this today, but I'm going to teach some parts of the module that actually didn't exist in the slide. Okay. I mean, didn't covered by the slide syllabus. Okay. So for those that having the module, you can turn to page. Where is it? Okay, you can turn to page 295. Okay. For those that having module, you can turn to page 95. And those that actually watch my video, do you guys watch my video? The one that I asked you to watch, because it's already in the video. It's covered in my video. Okay. Here. Okay. You guys are very lucky. You just even need to already watch something that actually my video 2021 is more complete. Okay, so there is two videos. Okay, where is it? 17. Eh? Where's the video? 17 April. Wait, this one. So there is actually two. This one have been asked to watch before this last week, and this one is additional. Okay, this is okay. So this one actually will be covered today, just a little bit at the back, which is about mixed logic. Okay. Wait, it's annoying. This one. Okay. Actually, my personal view about this website, those that asking for sedekah is good, but for me, it's too a lot that sometimes I wonder if it's true or not. Okay, I mean, whether it's a valid association asking for donation or not, because there is, Malaysian, they are kind. Malaysian are kind, so we sometimes we end up we helping the we not we helping the wrong people. Maybe they are syndicate. Okay, syndicate in getting our money, because a lot of adverts asking for money. Okay, so this is the video combinational logic 5. Okay, logic level part 5. So it's actually covering about the mixed logic. Okay, which didn't covered by the slides. Okay, so today we're going to cover that briefly, because it's already covered in the slide in the 2021 video. Wait, wait. I'm asking my student. Never mind. Okay, so mixed logic, those watch the lecture video. Today is just a brief. Okay, so page 95 is about the mixed logic. So things that we actually been familiarized until now is actually we have been using logic polarity, which is positive logic. Okay. However, hello, Marilyn. Sorry. Hello. Eh. Okay. So we have been using positive logic. Means the polarity. Okay, polarity. For example, in a battery, in a battery, for example, okay, polarity. Okay. So for what we have been learning until now, okay, is positive logic. Okay, we learn using positive logic. Okay, so positive logic. So actually, there is another one. Okay? Actually, negative logic. Okay. So what is different between these two things? Positive logic. Okay, I'm not clear. Wait. Okay, so I hope my voice is clear now. Wait. I don't like using this because it's not friendly. But I have to use it because it's one of the things that actually I can record. I can record unlimited. You guys can listen to my voice now. Is it okay? I was searching for earphone just now. Okay. Okay. So, okay, where was I? I'm quite disturbed already today. Okay. So positive logic is what is okay, what we learn is that we have logic 1 and logic 0. Okay. So in positive logic is that the in positive logic, okay, the logic 1 is more positive than logic 0. For example, you have this is 5 volt, be taken as logic 1, and the lesser one will be 2 volt will be taken as 0. This is positive logic. Okay. For the negative logic, it is in on the contrary. Okay, Dr. Izzati is responding to me now. They say to me, he said this one using her class 11 to 12. There is no clash. Okay, now I'm confirmed. I'm a bit sad lah because uh, okay, maksudnya tak clash lah. Okay, aku nak confirm je sebab aku confused. Okay, so in the negative logic, what you have is actually in reverse. Okay, the one is actually more negative. For example, less positive. For example, negative 3 volt. Sorry, negative. Maybe 3 volt. And the other one is 4 volt. Okay, 4 volt. This one I put as in terms of analogy. In terms of analogy. Okay, in terms of analogy. So that you understand the concept. So this is positive logic that we have been learning so far. And there is a negative logics. Okay. So if you have I'm not sure if you guys have not all of you have the books, right? Okay. So imagine that we have an input of AB and output of F. Okay. And output of F. Then we have, for example, if we have a combinational input, okay, combinations. So we can have either low, high, high, low, and high, high. Okay. And the resultant, for example, we have a low, 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 and high. Okay. For this one, we didn't know what is inside. It can be any. Okay. It can be any. It can be an N. Okay. Let's say this one is a positive logic. Positive logic. This one is negative logics. So it can be an N inside. It can be an OR. It can be a NAND. Okay. And it can be a NOR. Okay. So if you want to convert to the equivalent, negative logic, okay, the N is OR here, and the OR will be an N. If you don't understand, never mind, we go to other example later. And this one going to the NOR, and this going to be the NAND. You just need to reverse it, okay? Just like to its convenient, N to OR to N, NAND to NOR, NOR to NAND. If it's going to if you want to see the equivalent in the negative logics, okay? So if we have this table, okay, now we're going to see the case. We're going to see the case, for example, A, BF, the same, okay? Let's say we have low here. In the positive logic, okay, in the positive logic, the low 0 is actually more negative. Okay, more negative means like this, or more negative or less positive, the way we're going to see that. Okay, the way we describe. In the positive logic, the 0 is less positive or more negative. You can use either. Okay, so we have here 0 0 0 1 1 0 1 1 combinations. Okay, so if you have this one is all LLL 0 0 0, so it's actually 0 0 0 1. So this is actually what? This is actually equivalent to a AND gate. Okay, equivalent to the AND gate, because it needs all the input to be 1. Only then you get the output of 1. So A, B, and is actually a AND gate for the positive logics. Okay. Now we see for the other table. Okay, this one is positive logic. Now we see the negative logics. Okay, I am not good at drawing, but the important thing is you understand. Okay, now here is negative logic. In negative logic, it is reverse. Okay, you see it is reverse. So if the low is actually more positive, so it's actually 1 1, low 1 0. What happened? Battery habis ke? 1 0, 0 1, and 0 0. Okay, like this. And the output here is, because this is low, low is actually more positive, right? So this one is actually 1, 1, 1, and 0. Okay. So if you notice this, all of the inputs actually having 1, except for the only one that actually didn't giving output of 0. And if you notice this, didn't give output of 1. If you notice this, it is totally inverse of the positive logics. Okay. So from here you see just inverse. So it is inverse because you see 0 0 different, right? 0 0 here, but however in here is actually inverse. Okay, you can see all of the parts here is inverse, 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 inverse. So that's why a for a you have to put a bubble because it's inverse. Okay, and then the next this one as well for the b is inverse, so that's why b inverse. Okay, so you have bubble there. And you see the output also having inverse. So it's inverse. Okay. So this is how it is. So you may try at your own leisure time to try with the NAND gate, to try with NOR gate, NOR, and the NAND gate. So I'm not this is not so much about the mixed logic, but still it can be asked in your exam. Okay. So do you guys want this? No need, right? Or you never mind. It's okay, okay. I think I just take this because who knows you need it. I'm not sure you guys need it, but I just put okay. So the next part is actually go to the page 96. Okay, for those that have the module, go to the page 96. Those that didn't have, no worry. That's why I'm doing right now, so that hopefully it will helping you. Okay. So the next is actually every gate can be drawn in two ways in mixed logic. So if we have the basic symbol, okay, basic symbol, for example, okay, basic symbol, this one is N, this one is OR, this one is the NAND, this one is NOR, and this one is NOT. Okay, so let's say we want to find the De Morgan equivalence. Okay, do not memorize if possible, but you try to understand how to get this. Okay, so this one is De Morgan equivalent. Okay, for example, let's say you have A and B here. For example, this is A and B. Okay, and this is F for the output. So F equals to AB. Okay, F equals to AB. And we know that actually F double bar is equals to F actually. Okay, so let's say we want to see F equals to F double bar. Okay, equals to AB double bar. And if we apply De Morgan's theorem, it's actually A plus B bar. Okay. So that's why if you want to see the equivalent in De Morgan's, okay, you can see is A, B, and inverse, so bubble, and it's OR, and another bubble. Okay, now understand? Understand or not? How actually we get this? Okay, we implement De Morgan's theorem. Understand? Understand or not? Thumbs up. I worry if you guys don't understand. Okay. Because for me, no problem for me. I'm not going to sit for the test. Okay, so this one, please test. Please test at your own leisure to prove this concept. So this is for the OR. Okay. Also the same with bubble. And then this one with bubble. Okay, test yourself at home, because you do not just take whatever people say to you without trying to understand. So one of the way try to understand is actually try to prove them. Okay. Okay. So this is the equivalent of the basic symbol in terms of De Morgan's. Okay. I take this also, put to the slide. Okay. Oh. Okay, so now we go to the other. Where's my pen? Okay. Okay. So go to the new page. Okay, I mean, go to the new blank page. Okay. So whatever covered by figure 7.14, which is just now, the basic symbol and De Morgan's equivalent is actually shown in the, please read the paragraph. Okay, now what else? Well, I am trying to see because it's not covered in the slide. Okay. Okay, so okay, this one. Okay. So, okay, let's say we have a circuit, okay, or circuit. This one is A and this one is B. Okay. What is the output that you gotten is A plus B, right? Because this is OR gate. Okay. So, because this one inputs and output, they didn't involve a complement, didn't have inverse. So this one is actually, we call it active high. What does it mean? Is that the link here is turned on when it is actually high. Okay, or something like that for easy understanding. And this one also the same. The output is also active high. Active high. To get a 1 here is actually you need the high. So it's an active high. In converse, if you have something like this, okay, the equivalent for OR gate, the equivalent is actually a NAND gate, a gate of N with bubbles. Okay, so you see here is AB, here is AB. Okay, so this one actually equivalent with this one. So this is the De Morgan equivalent. So you see there is bubble. So means that this one is an active low. Okay. The A and B need to be 0 because 0 will be inverse. 0 will be inverse and we goes to here inverse S1. So this one is actually, we call it active low because of the bubble present. Okay. Because you need to input signal of 0 for it to be active. Okay. Okay, so this one is what we call as an active low. The same as well for the output. Okay, it need to be active low as well. Okay, so make sure if the question asks you, okay, if the question, for example, the question can ask you, for example, AND gate with active low input. For example, there is, for example, an AND gate with active low input. What does it mean? AND gate with active low input. Understand? You need to see the word very carefully. Okay. Then so we finish with that. So this is the things. Okay. Make sure you know this one is not really important. I mean, not really covered in detail in the module. However, the question can ask maybe anti-final exam can try to. I mean, mention to you, or active low, active high. So if you don't understand the concept, it will be a problem, even though it doesn't cover so much in the module. Okay. Okay, this page 97. Okay, go for those that having module, go to page 97. Okay, page 97. So so active low signal. Okay, so we call it active low signal. Okay, can be identified in several ways by having an over bar, over decimal, or by prefix n, indicating a not function or asterisk. Okay, so let's say you have a reset. Okay, if you have a reset, how are we going to know this actually involve active low signals, which is just now. So it's either you have a bar here to show you the active active low signal, or another one. Let's say you have reset. Okay, by and having the words of n here. Okay, so this is also means it is an active low signal, so you need to actually input 0 for it to be active. The next one is actually you the way of wording, you have reset. Okay, this one. So both, there are three ways in actually to represent it is an active low signal. Okay, so some signal have different meaning when high or low. Both meaning of the action performed by this signal are given in the same signal, separated by the symbol. Okay, so never mind. So let's say we have a read here. Okay, for example, in a chip, okay, read slash write. Okay, with a bar. Okay, so you see here how we going to read this actually. Okay, you see there is two possibility, is either high or low. So you see this one is high. Okay, it doesn't have inverse, so it's actually when it is high, the operation done by, for example, the chip is reading the data. So this one is read when high. Okay, but when we have high, we also have a low. What if we have low? If low, it's going to do some writing. For example, we input data. If write, we only read the data. But write, maybe we're going to need to add more data. Okay, so if it's low, it's going to do a write operation. Okay, so this is what does it mean by that. Okay, then we have another one. We have M and we have IO. Okay, with a bar. So what does it mean by this? Means when it is high, okay, when it is high, it's going to access the memory. Okay, when it is high, it's going to access the memory. Okay, and if you have it low, okay, the one with having bar here, so sorry, this one, okay, having the bar. So if it's low, what does it do at this time is actually the input and output when low. Okay, means it's going to access, going to have some changes at the input and output when it is low. Okay, so finish with that, and then you see 7.5. Okay, 7.5, you guys read at your own. I think this one is not that difficult, 7.5, but let me know if you guys don't understand. Okay, 7.5. Okay, now try. Okay, 7.3, wait, because you already finished, I don't want to go to the next chapter. The next chapter is multiplexer. We're going to cover multiplexer after mid-sem break. Oh, sorry, wait. We have another class, right? Yes, we have class on Wednesday. So on Wednesday, we will cover multiplexer. Okay. we will cover multiplexer until we only cover multiplexer only lah. Okay, but we'll do that later. Today we only finish chapter 7 the combinational logic design. Okay, so read earlier on for the 7.5. Let me know if you don't understand. Okay, so now I try to see what is the exercise that you can do. Okay, ad hoc now before I let you go. Okay, 7.5. Let's see what kind of exercise. Okay, wait. Design 7.5. Okay, are you dah ada buku tak? Do you have the books already? Do you have the books already with you? Module. Do you have module already with you? Where are you? Where are you? Where are you? I'm talking to you. Are you there? Or actually you actually dah kantor? You actually not here. Are you? Where are you? Okay. Never mind. I'm going to see if we can do one exercise. Okay. And I let you go. Wait. I'm trying to see what kind of exercise that we can do together. Not so difficult that it can be done in the class. Oh, kantor. Okay. Sorry. Okay. So, okay. Try to do this one. Okay, this one is very easy. Not very easy. I mean, the question is actually very simple, but it needs some time, some task to do. Okay, so we go to the pen. Am I sharing the screen? No. Okay, so try to do this. Okay, we will see in. I will create a Padlet. Then we just finish the class because we actually covered. We actually covered many things. Okay, our class in advance, but that's why my class. We are fast progressing. However, I because we are fast, I mean progressing fast. That's why I can give you more exercise. Hopefully, it will help you for your test and your final. Okay, so now try this one. I'm not sure if you guys have answer, but be honest, because the module have answer, I know, but maybe limited answer or maybe complete, I don't know. Okay, so design a BCD 2421 to BCD 8421 converter. Try. I give you around 15 minutes. Because why I give 15 minutes? Because this question, okay, if I'm correct with the last syllabus, because the syllabus keep on changing. I didn't teach for last semester, but I teach for the last 2 semester. I mean, I only teach this subject for 2020, 2021 too. Okay. Maybe there is changes in syllabus for 2020. Actually, there is changes. We know. We have been informed by the coordinator there is changes in the syllabus. So I only teach during this time for this. This one I didn't teach. This time is the actually where the syllabus have changed. Okay. So if the syllabus didn't change, the question about final, I mean the question about design, okay, the question about design circuit whatsoever is actually only been asked during final exam if my information is still correct. Okay, so I'm not sure. Maybe test can ask design question. I'm not sure. So that's why try to do this. I give around 50 minutes. Okay, try design a BCD 2421 to BCD 8421 counter. What should you do first is actually you try to do the KMAP first. Okay, so okay, so I give 50 minutes. 3:30 we will discuss. Okay, try to do this. design a BCD 2421 to BCD 8421 converter. Okay. So I give 50 minutes. Of course, the first step is actually to do the truth table. Is it 7.5? It's 7.5. Again, I will only checking for the step. Okay, I am only checking for the step because the important thing is for you to get the step correct. Okay. Maybe you guys have the answer because I don't know how much the module have answered. Okay. But try first. Okay. If you don't get it correct, it's okay. Make mistake now is far better than make mistake during final exam. BCD 2, BCD 2, 2, 1, converter. BCD 4, 2, 2, 4 to 1 converter. Okay. So the moment it shows binary, binary coded decimal mean the largest number that should be present is from 0 until 9. Okay. Converter. I hope the book teach you guys. Okay, the book teach. Okay. So you need to use truth table, then you need to use K-map, okay? You need to use K-map. Again, I don't have the answer. I don't have the answer. I will be doing the same as you. Hello? Hello, tak apa, tak apa. Tadi saya nak tanya sebab you kan ambil anatomi juga kan, SEM ni kan? Siapa ajar you Dr. Izzati ke? Oh, tapi test pukul berapa? Ah, 11 sampai 12 kan? Test 1, test 1. Okay, I give okay. This is actually a final level question. But for final, I mean this one is like final question, but it is easy question. So you try first and you see whether you can do or not this question. Okay. So first of all, you need to know the inputs. You need to do the you need to do the truth table, and after that you will do your chem map. Okay. And then you need to do your logic circuit lah. Okay. But it's going to be a lot because this one is it's to 4 bit. Okay, last time if I not mistaken, okay, you must be aware there will be a question on designs. Okay, however, okay, if my memory serve me correctly, you don't get a design question in your test. You will only get during your final because design question quite challenging. If we given to you, I think in my opinion, if we give you during the exam, I mean during the test, maybe not enough time lah. Okay, so that's why the design question will be reserved for the final. However, if you are a hardworking student, okay, or you want to excel in this study, do not wait until the final. Only then you study about design question. Do not wait like that. Okay, you should be doing preparation exercise now. Okay, from the module. That also one of the reason why I'm forcing indirectly for the student to do the module, because if you didn't do the module, maybe you didn't cover the syllabus. Okay, because the module covers the syllabus, and whatever exercise given by the module is very very beneficial if you're going to do it. Okay.
Doctor,
Hmm?
for the truth table, right?
Yes.
Ada condition ke like we have to put? Because I can construct the
Hmm.
macam nombor, but then I don't know what to put for the F.
For
So
the F is this lah, 8421. Okay. Can I erase this everyone because I need to uh explain. I erase them. I need to erase
yes,
the page. Okay. So okay. So the question is asking 2421 to 8421. Both BCD both BCD. Bunyi perut saya ni lapar. Kejap kejap. Nak tergelak saya perut saya. My stomach is making sound because for me I didn't for me I only sahur I only sahur water. Okay. Eh Akila, nanti you baca soalan ni, saya nak buat buka. Okay, wait, don't save. Okay, what is the question actually just now, from what to what converter?
design a BCD 2421 to
BCD 2421.
2421 to BCD 8421.
Okay. So what you should do is actually, because this is a BCD, and actually for BCD for binary coded decimal. First of all, you guys need to understand first what is binary coded decimal. Binary coded decimal is a binary number. However, it only represent the number that is available in the decimal system. in the decimal system, we only have number 0 until 9. Am I correct? Am I correct? 0 until 9, right? Do we have number 10 as a symbol in the decimal? We don't have, right?
No.
So we only have 0 until 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, in the decimal system lah, in the decimal system. Okay, we didn't have the other 10, 11, 12. We didn't have. So that's why until 9, it is only to be represented in terms of 4-bit only. Okay, for the BCD. Okay, we didn't care about 10 until 59 because in decimal we only have symbol 0 until 9. So now BCD 2421, okay, is the input, okay, 4-bit, and your output should be BCD 8421. Okay, so how we actually use this, for example, okay, for example, if you have okay, I want to see the one that having difference. Okay, for number 5, you say you have 0, 1, 0, 1. Okay, this is the common. So 0, 1, 0, 1, 0, 1. So if 0, 1, 0, 1 means the one, wait, that's why we do it now, so that we have wait, I'm trying to see. Okay, you go to page 21, those that heavy module. Okay, those that didn't have, it's okay. That's why I'm here. Okay, don't worry. Okay, so for number 5, okay, for number 5, for example here, if you see this one, okay, if you see this one, in order to get 5, okay, in order to get 5, we have a lot of combination for the 4-bit. We can have, for example, this one, okay. If you want to take for 5, we have option of, if you want to get number 5, we can have option of 2 to 1, okay, 2 to 1. We can have 1, 0, 1, 1, okay, because this equivalent to 2 plus 2, 4, 4 plus 1, 5. We have another one, which is 4 plus 1. Okay, like this. We at least have 2. Okay, now, what number should be selected to be our 5 here? Okay, so in doing this, you should actually choose the combination that having the lower weightage, the most lower weightage. So you see this one, it is used until 2 to the power of 0, 1, 2, 2 to the power of 2. This one is using until 2 to the power of 3. So when we have a common number that can represent by more than one combination, we should choose for the BCD, the one that having the lower weightage. So this one, the biggest is 2 to the power 2. This one is the biggest of 2 to the power 3. That's why we choose this one. Okay, instead of this one. Okay, settle with that. Now the next one. Okay, the next one is to find the BCD equivalent, similar case. Okay, so you see BCD here is 841, but how are we going to get our combination of 5? Okay, the most smaller weightage is actually we're going to have wait, terbalik ke ni? Okay, so it's correct. Okay, now 841. So 84 wait for one. Wait for one. Macam terbalik je ni. Sekejap wait
Saya terbalik.
table ni terbalik. Table 2.7 terbalik kan? Do you guys see the module? The table is like inverse, kan, Akila? The table tu terbalik lah. So for this one, Do you guys see the module? The one that heavy module is terbalik.
Yes.
Terbalik. So for this one, it should be for this one you only have this option 0 1 0 1 because 4 plus 1. So 0 0 1 0 1 kenapa ni? Jap sorry. 0 1 0 1. Okay. This one, wait what is going on wrong with here? Okay. So sorry. I am the one making mistake. I'm sorry. So it's here, fourth one is producing 5. Okay. But here, okay, here, you need to see the lower weightage. The lower weightage you see here. Okay. I'm sorry. I'm making mistake just now. Okay. Because the table here is not the same with the table that I'm using. Okay. So it's confused my mind just now. Okay. So for 2 4 to 1. Okay. For 2 4 to 1. So you see, you need to take the lower weightage. So the lower weightage, you can see this one, and this one will produce a 5. So that's why you put 1 0 1 1 instead of choosing 4 plus 1, which is 0 1 0 1, because this one is higher weightage. Okay, you need to choose the one with lower weightage, which is 2 plus 2 plus 1. Okay, instead of 4 plus 1. Understand? Do you guys understand me? If you understand, please thumbs up. I am sorry, just now a bit error because the table that I use is reverse with the table in the module. That's why I'm become pening skip just now. So okay, so complete all this. Okay, complete all this from 0 until now. Then you do the K-map. The K-map, okay, the K-map that you will do later, A B C D with the uh, with this as the input, but the output will be BCD at 4 to 1. So you will have what? You will have don't K condition. Okay, try to do it. Okay, try to do it. Complete this one first. Then you go this one. If you want to fast, you can see the module. But if you want to learn, you do yourself. Don't refer to the module. Okay. So I give another 15 minutes. Actually, I have meeting at 4. I have meeting at 4 p.m. Try first. Okay. Again, I don't have the answer. I don't have the answer. But I want to see whether you can do it or not. I don't have the answer. Even I don't have the answer for this question. Okay. I do the Padlet now. I don't want to wait till final. Only then we discuss then problem. Okay. At least we discuss some design question now. Okay. SEU 1 2 2 3 0 3 0 4 0 4 lecture. Okay, try. Okay, 350. You try to share your answer. In the Padlet. I'm doing the Padlet right now. Again, the important is not the answer right now. The important is whether you do the step correctly or not. I want to see that. Because I cannot check for answer right now because it will be difficult, a lot of you. And I don't have the answer as well. I can do, it will take some time. Okay. Okay. Edit, save, back, share, copy link to link bot, copy link. Okay. So another 12 minutes. Okay. Okay. The important thing is for you to try. Don't Google because don't Google for the answer. You try. Okay. Don't Google. Don't refer to the module. Try. If you want to really learn, try to convert yourself. Okay. Design a BCD 24:1 to BCD 84:1 converter. So because this only cover until 9, means that in 4-bit, we didn't use 10, 11 until 15. So for sure, there is a don't care condition. So in your K map, should have a don't care. Okay, another 8 minutes. Another 8 minutes. Okay, share your answer at Kmap. At Kmap pula. At Padlet if you have done it. Okay. So another 5 minutes. Remember, I didn't check for answer. I check only for the working step only. Until you do the logic gate. Until you do with the logic gates. Means it's until you do logic gate and some expression, then it's complete. Just like what we did for the previous uh, and the previous exercise, I mean the lecture, however, is only the difference is that it is on design now. Okay, means purposely given you an instruction, design this one to convert to this one. So you need to analyze first. Okay, remember the basic step, conceptualize. Um, it, the fourth step that we learn in the doing the logic circuit at which page? Where is the page? In the page of 85. First, you need to conceptualize, means you need to understand what is happening actually and what is required. Okay, and then after that, you do the truth table, and then after that, you do the equation. Okay, you may use Kmap or you may use Boolean algebra to simplify the Boolean expression, and after that, you will do the circuit diagram. You will do the circuit diagram with the logic gate of the simplified one. Okay, for the simplified Boolean expression. Okay. Oh, no one do it yet. Joey, is it difficult? I think it's not difficult. It's just maybe it takes some time. Am I correct? I think it's not difficult. The question is not difficult, but it takes some time. Am I correct? You guys? I want to see you guys can do this. Then maybe I will be a bit comfortable. I mean a bit relieved.
I'm not sure to my answer.
You're not sure to your answer. Hmm. You- at which step are you now, Joey? Is it Kmap or what?
I use Canmat.
Oh, you at Kmap. Okay. For example, at 0000, so the Kmap also having oh, interesting. I know now why are you guys confused. It's okay. So for example, this one for 1011, okay, for example for 1011, so you have 00, okay, that we see for example. I think I know maybe what you guys not sure you understand or not. Okay, says you see 00, 01, 10, 11, 00. I think after this I explain this, maybe you guys can do already. 10, 11. Okay, so ignore this one. So first is 1011. 1011. So this one 1011. 101 you get a 0. Actually it need to be, this one is for the bit 1, and then you need to actually have 4 kmap. Understand or not? Now understand? You guys understand or not what I'm saying now? Means that you need to have 4 kmap actually. 1 kmap this one, 1 kmap this one, 1 kmap this one, and 1 kmap this one. Understand? So okay, I give you guys to do at home. Okay, and submit to me. Okay, I'm doing the forum right now. Wait, because this one is important. It's important that you know to do it. Okay, because you will get this kind of question during finance. So I make a forum now, and not forum assignment. Okay, I know it's not enough time, but you try to do after the class. Okay, I want to see whether you guys can do it or not. Okay, today is 24 of April. 24 April, where's it? 24, 24. Okay, 24, this one. Okay, so I put as assignment. Okay, but I know you guys are doing my quiz also, but try to do it. It's actually not difficult. Not difficult, but it's going to take some time. Okay, so I go for the assignment. Okay, assignment design. What is the question just now? Do not wait until final, only then you practice. Then you will be in problem like that, because you don't assume the question will be easy like this. This one is very easy kind of question, the one that they give right now. Okay, design a BCD 2421 to BCD 8421 converter. Okay, so this is assignment. So I give it to be done from now. From now 4 p.m. Okay, until it's okay. I give you some time. I give until 20. When is it? 26. 26 Okay. Is it okay? 26. I give 26. Also the same. 16 means 2 hours. I mean 48 hours. Is it okay? Is it okay? 2 days. Actually, you can do now, actually, after the class. But I know you guys maybe need some rest, need to buy something. I actually no rest. I have meeting after this. In another 8 minutes, I have meetings. So please submit. From 24 April today, 4 p.m. until 26. Mean I give you 2 days just to try to do not copy. Don't worry, do not copy. It's okay to make mistake. Do not copy one another. We try to see whether you can do it or not. But I already give you, right? I already give you some hint. Okay? Means there will be 4 kmap. Okay? There will be 4 kmap. So you're going to have 4 output. You're going to have a 4 output. Okay? So so I push here. Okay? So submit when you finish. Okay? So with that, we finish the class. Means that we already finished on the combinational logic design. Next week, and not next week, this Wednesday, we will start with multiplexer. Okay? We will start with multiplexer. So please submit your assignment to here. Okay, due date 26. Okay, due 26 April to 4 p.m. Malaysia time. Okay. Okay, thank you. Assalamualaikum. Have a nice day. Okay.
Thank you, Doctor. Assalamualaikum.